Hi all, welcome back to my channel Learn with Girish. In my previous session, we looked at Azure OpenAI service and some of the model it supports. In my today's session, we will take a look at Azure Machine Learning Service and also we'll take a look at the different models available as part of this service. And then we will look at the new vector search support in Azure Cognitive Search service using the Langchain Framework. And finally, we will take a look at a notebook wherein we will use all these service, wherein we will take the data and convert that data into vector embeddings and then push that vector embeddings to Azure Cognitive Search service and then do a search on top of that. So with that, let's start the session. Here, I have already created a Azure Machine Learning workspace in the Azure portal. So once you have this service, you can click on the Launch Studio, which would take you to this screen. So this is the Azure Machine Learning Studio, where you have all the features required for you to do end-to-end lifecycle of your machine learning workflows, including the data, creation of pipelines, including the creation of models, and also the deployment of models, including the monitoring part. So if you see here, we have some features in preview, the model catalog, the prompt flow, and the monitoring. So these are some of the new features which were specifically introduced for generative AI. So in this session, we will take a look at model catalog, and in my future session, I will talk about prompt flow and monitoring. Let's take a look at the model catalog. Once you click on this link, you would go to the screen where you can see all the models which are made available from different companies. So if you click here on the view models in this style, you would see all the models which are available from Meta. So if you go to any of these models over here, right? Let me pick Llama 2. Here you can see all the model details, including the training data and the hardware and software which it was trained on, and also some evaluation results along with a few examples on how to use the model. So you can directly deploy these models by clicking on this button and then start using these models. So in my session, we will be using Azure OpenAI models. So I'll click on this one. So here we would see all the models available from Azure OpenAI. We will use text embedding ADA002. So this is the embedding model which will convert the text into embeddings. I'll click on this one and deploy it in my Azure instance by clicking on here. So this would use Azure OpenAI resource for deploying the model. So if I click on that, I can see a message that only one model deployment can be done. So I have already done the deployment. So let's see the resource over here. So after deployment, you would get an Azure OpenAI resource. And once you go to this resource, you would see that the text embedding ADA002 model is deployed in that instance. I have also created an Azure Cognitive Search service in my resources. So here I am using the basic tier which supports the vector search. Now let's take a look at the vector search in Azure Cognitive Service. So this vector search is a new capability for indexing, storing, and retrieving the vector embeddings from a search index. So you can use this kind of search if you are planning to implement a pattern called as RAG, which stands for Retrieval Augmented Generation, which I covered in my previous video also. So you can use this pattern if you want to prevent your model from hallucinating. The way it works is you would have different data sources, including the images, the audio, video, and text, and these would be converted into vector by using an embedding model. and these vector representation would be pushed to the Azure Cognitive Search service. And once we have the search query either from the app or from the user, these search query would again be converted to a vector representation using an embedding, and then we would perform a matching from for this vector in our Azure Cognitive Search service, and then retrieve all the matching results to the user or the app. So the search results which are returned uses this algorithm called as k nearest neighbors. So this is a similar kind of algorithm which is being also used by Google search and YouTube search. Uh, and also you can use this pattern in your organization to build a search as a service or organization wide search service. So the limitations which are mentioned here is like by default Azure Cognitive Search Service does not generate any vector embeddings. So for that we are using Azure OpenAI model for doing the vector embeddings. And then here we are using the Langchain Framework integration with the Cognitive Search Service. This makes it very easy to generate the embeddings and also to do the search. Let's take a look at the Langchain integration. Here you will get all the details about how do we use Azure Cognitive Search Service using Langchain. So here they have provided the different commands which we will see shortly in a notebook. So in this session, like we are using the Azure Cognitive Search as the vector and using OpenAI embeddings. In my previous session, we looked at a different vector search engine called as FAS, which is provided by Meta. And also we looked at how do we use the Hugging Face embeddings instead of OpenAI. If you are interested in that, you can take a look at that video. I'll provide the link in the description. So with that, let's take a look at a notebook which shows all the integration. Here, first I would install the different Python packages for search, OpenAI and Langchain. And then here we will use different APIs, mainly the OpenAI embeddings to do the embeddings, and then Azure Search. This API would be used to push the vector into Azure Cognitive Search Service. Then I have certain keys here for OpenAI as well as the Azure Cognitive Search Service. And then we will create an instance of OpenAI embeddings. And here, just to show like the vector representation, I have a text, and then I would use this embedding instance and embed this query, and this would how the vector representation would look like. It's a very long text. So to understand this vector representation, I have provided one example over here. So here I am taking all the cities from different geography. Some are from US, some from East, and some from Europe, and some of them from India. So with all the cities, I'm using the embeddings, and then using a little bit of scikit-learn to plot the different vector representation. So this is how the vector representation would look like. If you see here, all the Indian cities can be grouped in this bucket. And similarly, all the cities of the East can be grouped over here. And uh, and all the cities of Europe, right? We group it like this. And all the US cities, we can have a grouping like this. So with vector representation, the model already knows like where does this vector belongs to. So this is how it is stored internally. And then we would create an instance of vector search. wherein you would pass all the search details, including the password and the index which has to be created. In my case, it's Langchain vector demo, and also the embedding function to use. And then what I will do is I have a text over here, a sample text with some random content over here for testing the search. So what I will do here is use the Langchain APIs to split that document and create different chunks of size 1000 without any overlap, and then push these chunks into the vector store by using this command. So this is how the different chunks would look like, and then these would be pushed to the vector search service. And finally, we can do a search on that using the Langchain APIs. So here I'm specifying the query as Putin, and here you will get all the results with respect to Putin and also with respect to Russia. And also we can do a search called as a hybrid search, which will just not do the similarity search, it will also do a keyword search. So here I have mentioned it as America. So it would retrieve all the results from America. So that's all I wanted to cover in this session. I hope you like this session. Do press the like button and subscribe to my channel if you want to see more videos like this. Thank you for joining the session, and see you in the next video.